next type of factoring we're going to look at is factoring some of those special ones. If we have, let's do this first, x minus 6 times x plus 6, okay? If we FOIL this out, we get our first is x squared, our outer is 6x, our inner is negative 6x, and our last is negative 36. And we discover that those go away, leaving us with x squared minus 36. We talked about this being the difference of two squares. The difference of this one squared, difference means minus, and this number squared. Now, whenever we see these though, we want to be able to go back to their factored form. So their factored form, well, I know x squared is x times x. Okay, I know 36 is 6 times 6, and a minus means I have different signs. So I have a plus and a minus, okay? Can you do this other ways? Yes, you can. If you think about this being x squared plus 0x minus 36, okay? I find my a times my c is negative 36. My b value is 0, okay? And I set up my box. Okay, I have x squared here and negative 36 here. Okay. Now, when I do this, I can have 1 and 36, but that is 35. That doesn't help me. I have 2 and 18, but that is 16. That doesn't help. I have 3 and 12. That's 9, so that's not what we're looking for. I have 4 and 9, which is 5. Again, not what we're looking at. And then I have 6 and 6, which is 0. Okay? I have a plus 6 and a minus 6. But what we notice is, all right, here's the 6 that they agree on. Okay? Sorry. Here's the x they agree on. This is also the 6 they agree on. And this is the x they agree on. X times x is x squared. X times 6, we're going to need that negative. Now, x times 6, that's where we need the positive. So even if you work it out in the way that we've been learning, it's still going to give you the same thing. So do you have to memorize this? No. Could you? Yes. So if we look at another one of these, if we look at 100 minus m squared. All right, well, there's only two terms, so that's my first hint. There's a difference, and I know the square root of 100 is 10, and I know the square root of m squared is m. So that gives me 10 minus m and 10 plus m. Okay? So if you notice that, you can go ahead and take the difference of two squares, which will go back to this piece here. One other one we'll look at is 9n squared minus 16. Again, there's two factors. It's a binomial. Usually we would have a trinomial. I know 9, the square root of 9 is 3, and the square root of n squared is just an n. I've got a difference. And I know the square root of 16 is 4. Now remember, because our root is 2, that means there's the plus or minus. So there's the minus, and here's the plus. Okay. Again, if you don't remember this, you could easily use your box method. It works fine. Now, what are some of the other specials? That is the one that makes it much easier if you can remember. Let's look at this one. M squared minus 2m plus 1. Okay, so a times c is 1. My b value is negative 2. Okay, I know that I have to have the same signs and they're both going to be minus. So I know immediately it's going to look like this. If I make my box, m squared goes here, the 1 goes down here, Okay, well, my only option for 1 is 1 times 1, and when they add together, they get 2. But I need a negative, so -1 times -1 is -2. Or -1 plus -1 is -2. So -1m and -1m. So let's see what they agree on. So this way, they agree on an m. This way, they agree on a 1. This way, they agree on an m. And this way, they agree on a 1. So I know it is m and 1, m and 1. Let's check our signs, though, to make sure it is really a negative. M times m is m squared. M times 1, we need a negative. There we go. So m times -1, there we go. That's the -1m. 1 times m, need a negative. -1 times m, yes, that is -1m. And negative times negative is positive. So this is correct. This is what is known as the perfect square trinomial. Do you need to memorize this one? You could. We can simplify this even more to m minus 1, the whole thing squared. So if you realize this one is squared, the first term is squared, the last term is squared, and this one is the a times the c times 2. So if you realize that, you could definitely use this, or you can use your box method again. Alrighty, let's look at one more of these just to try it and to see. Let's look at, let's do this one, a squared plus 6a plus 9. Okay, and we're to set it equal to 0. All right, it's not a difference of 2 squares. Okay, maybe I'm saying something, but if not, let's just look at it this way. I know they have the same signs. Okay, right away I can divide it into the same sign, and the sign's going to be a plus. Okay, I know a times c is 9, and my b value is 6. Okay, I'm going to make my box. My first one goes here, my last one goes here. Okay, now 1 times 9, since we have the same sign, when we add them would be 10. That doesn't work. 3 times 3 is the only other factors in 9. 3 plus 3 is 6. That means this is 3a and this is 3a. Now, when we look for what is common, these both agree on, yes, an a. These both agree on 3. These agree on an a, and these agree on a 3. Now, we already know from looking at this, we have the same signs and they're both plus, but we need to check just in case. A times a is a squared. A times 3 is 3a. 3 times a is 3a. And 3 times 3 is 9, and it works out. We can see that this is one of those perfect squares. What that means is this is squared. Now, this time I did set it equal to 0, so let's go ahead and finish it and find our roots. So we're going to take a plus 3 equal to 0, but do I need to do the other one? No, they're the same thing, right? So I'm really just going to solve one of these, and I get a equals -3. So my only answer or solution to this is just a is -3.